In this video, I want to show you the solution to the quiz on tree diagram. If you did not do well in this quiz, then perhaps you should pay attention to these solutions. All right. In fact, the idea in this quiz is the fundamental of the more difficult tree diagram questions. Let's look at the first question, right? There are 5 fair cons. What is the probability to have exactly 3 heads, right? Now, before I tell you the right answer, let me share with you common mistakes, all right? Now, the first common mistake is that, so 3 heads, right? So each head is 1 over 2. So the answer is 1 over 8, right? Now, that is wrong. We do not do this because there are 5 cons. So you know that in addition to 2 heads, there should be 2 other tails. So exactly 3 heads means 3 heads and 2 tails. So the answer is 1 over 32. But unfortunately, it is still wrong. It is still wrong because the 3 heads, 2 tails, tree is going to repeat several times. Imagine you have a tree diagram. It goes heads and tails like this, right? There are 5 stages. 1 stage corresponds to each toss, to each con, all right? So for example, if you want 3 heads and 2 tails, this would be 1 branch. 3 heads and 2 tails. This particular branch will give you 3 heads and 2 tails. But in addition to that, we have another branch. Say we can have this one. Alright, and then HH. Right, it goes like this. The purple one goes like this. We have HTTHH. It is also 2 tails and 3 heads, right? So the question is, how many times this branch is going to repeat? We know that for 3 heads, the probability will be 1 over 2 to the 3rd power. For 2 tails, the probability will be 1 over 2 squared. But how many times this branch is going to repeat, right? So we can at the beginning, if you start to learn it, you can do it with manual counting, right? Let's count the number of ways we can put 3 heads and 2 tails. So I will do it systematically. For example, I will put all the heads first, or I will put all the tails on the far right, all right? And then I will move the tail one by one, like this, all right? So now we have the 3 heads and the 2 tails. There should be a tail on the far right. All right, like this, right? I keep all the tails, moving it up to the left one by one. Now that's all for all the tails on the far right. And then I would look at those with the tail at the 2nd position, like this, right? Once again, I put the tail, move up one by one, and fill up the remaining with heads. All right, once again, 3 heads and 2 tails. This is it, all right, for those who start with TH on the right hand side. And then I will move the tail 1 position further, like this. All right, we can have this one and this one. And then I fill up the rest with heads. Okay, so this is something more. What else? We can move the tail by even one more position. This one, all right. So it starts with this, but there's only 1 position left, all right. So I guess this would be all right. So there are altogether 10 different ways we can repeat this branch, all right. So it's multiplied to 10, and the answer will be 5 out of 16, all right. Now, I did it with manual counting, but if you're good at it, now that is the first stage when you begin to learn, all right? And then you can try to think about, you can make sense of that number 10. What does that number 10 means instead of doing it counting manually? Well, that number 10 comes from, there are 5 positions. There are 5 positions, and then you choose 2 of them to put the tails. So that would be 5C2, all right? There are 5 positions, and every time you choose 2 of them to put the tails. But at the same time, you can also think in this way. There are 5 positions, and you choose 3 of them to put the heads. So 5C2 or 5C3. If you do it on a calculator, you discover that they are just the same. They are both equals to 10. All right. So when you first started to learn it, you can do manual counting if the numbers are small, right? And then eventually when you finish the counting, you can try to make sense of that number, to try to think about the number in terms of NPR and NCR. And that is the best way to learn how to, count the number of branches without actually drawing the tree diagram, all right? So the same is very similar to question number 2. All right, we have 10 apples. We pick 4 apples, 1 rotten and 2 and 3 good apples. What is the probability? All right, for that rotten apple will be 1 over 10. For the 3 good apples will be 9/10 taking the cube. And that 1 rotten 3 good branch will be going to repeat 4C1 4 times, alright? A rotten apple and then 3 good apples. And then you move the rotten apple by 1 position. Alright? So we have this. So there are altogether 4 of them. Alright, and that 4 comes from 4C1. Also is the same as 4C3. Alright, anyways, the answer goes to 729 out of 2500. Alright, so this is question 2. It's almost exactly like question 1. Alright, the most important thing on this entire page are the blue numbers. Okay, are the blue numbers. Now let's take it one step further to next question 3. Question 3a is kind of like question 1 and 2, right? We want 4 wrong answers and 2 correct answers, right? So 4 wrong answers, the probability will be 3/4 to the 4th power. This number 4 comes from here, alright? 4 wrong answers, because we want exactly 2 correct answers. So the correct answers will be here, the orange number, right? That is for 4 wrong and 2 correct. Right, once again, you're going to repeat this branch, but by how many times? You can do the manual counting, ticks and crosses. 4 crosses and 2 ticks. How many ways you can line up the 4 crosses and 2 ticks? All right, that means among 6 questions, you choose 2 of them to be correct. So that would be 6C2 multiplied to this number. And that is the answer to part A, and it's 1215 over 4096. Alright, this is the probability to have exactly 2 questions correct. Alright, and then part B, we want to calculate the probability to pass. Alright, to pass we can have 3 correct, 3 wrong, 4 correct, 2 wrong, 5 correct, 1 wrong, or 6 all correct. These will contribute to pass. Alright, or alternatively, right, we can think about one fewer case. We can think about the failing situation. Alright, this will fail. Alright, 2 correct, 4 wrong, 1 correct, 5 wrong, or all 6 they are wrong. That will fail. Alright, we calculate the probability of fail, and we take 1 minus that answer will be the probability of passing. Alright, probability of passing will be 1 minus the probability of failing. So the first one, we can already copy the answer from here. For the other 2, we can do similar things. Alright, to have 5 wrong and 1 correct, the probability will be 5 wrong will be like this, right? 1 correct will be like this. And then this branch is going to repeat 6C1 times. Alright, and the last one will be this one. 6 all wrong will be simple, right? If you want to repeat the branch, this branch is going to repeat 6C 6 times. This is a 1. So sometimes you can omit this. Alright. So if you add up all these red answers together, that would be the probability of failing. So the answer to this one will be 1 minus 1215. And 5 wrong, 1 correct will be this one, right? You do the calculation, and that is 1458, and the last one here will be 729 out of a common denominator 4096. Alright, this is it. So the answer for getting a pass by random selection will be 347 over 2048. Not bad, alright, considering it is all random. Alright, so question number 4. There are 3 toys, right, equally likely. So the probability to get a complete set in 3 drawings, right, in 3 capsules would be the probability of getting the red one will be 1/3, alright. Getting the blue one will be 1/3. Getting the green one will be 1/3, alright. But this red, green, blue branch is going to repeat itself, alright. So how many times it is going to repeat itself? So we can think about this, right? Let's start with manual counting. You may get the red first, you may get the blue first, or you may get the green first, alright. If you get the red, it followed by the blue or followed by the green, like this. If you get the red, if you get the blue first, you follow by the red or followed by the green. If you get the green first, you follow by the red or you follow by the blue. Alright, so this is it. Alright, these are all the ways you can have red, green, blue. Imagine the tree diagram. Alright, the first one can be red, green, or blue. And then the second one could be red, green, or blue. The last one, once again, can be a red, green, or blue. And so on. Alright, we want to find out the branches that will give you all three colors. Alright, so this is one possible way. Alright, let me try another one. Okay, red, green, and blue, and so on. Alright, the tree diagram goes on. But some of the branches will give you red, green, blue. Say this one, red, green, blue. Alright, red, green, blue will give you the complete set. This one, blue, green, red will also give you a complete set, and so on. So how many triplets are there, right? We did the counting here. We know there are 6 possible triplets. So this number is multiplied to 6, and the answer simplifies to 2/9. That is the probability that you buy 3 capsules and then you get all 3 toys. Okay. Now then, we did the counting. We take one step further. How to make sense of that purple number? What does that number 6 means? Now we have 3 colors. All right, there are 3 positions. We put 1 color in each position. So the way to do that will be 3p3. This number 6 actually is 3p3. All right, you did the counting, but you do not know why. All right, but if you make sense, if you think about where that number 6 come from, you can understand more about the origin of the number 6. Actually, it comes from 3p3. All right, so that's for question number number 3 and number 5. Okay. Now let's move on to the last question. That is the question on the Kinder eggs. All right. So the first, the queen buys 1 box of eggs. What is the probability she has exactly 1 Snow White? Now once again, same idea. Now she buy 1 box of eggs will be 3 eggs. All right. To get 1 Snow White will be 1 Snow White, 2 not Snow White. All right. So to get 1 Snow White, the probability is 1/6. To get 2 not Snow White, the probability will be 5/6, taking the square. Alright, then number 2 goes to the square here. Alright. And then how many times this branch is going to repeat? 1 Snow White, 2 not Snow Whites will be 3C1. Alright, 3C1. So this is the answer in part A. That goes to 25/72. Alright. Roughly 1/3 chance to get exactly 1 Snow White in 3 eggs. Alright, that is part A. Now, part B is about at least. All right. Now, you can do all the calculations. Say 1 Snow White, 2 not Snow White, right, plus 2 Snow White, 1 not the Snow White, or all 3 of them, they are Snow Whites. You can add these probabilities together. But there is an easier way to do it for at least 1. At least 1 means that there's unless none. All right. At least 1 Snow White means that is unless there is no Snow White. Unless there is none. Right? If there is no Snow White, then there must be at least 1. So that unless will be 1 minus. Alright? Unless will be 1 minus. So no Snow White means that all 3 of them, they are not Snow White. Alright, so not Snow White, the probability will be 5/6. So the answer is just this one. 1 minus 5/6 taking the cube. And the answer goes to 91/216. Alright? The first one, 25/72, is the probability getting exactly 1 Snow White. The second is the probability getting at least 1 Snow White in 1 box, and that is 3 eggs. All right. So part C is the worst done question. Right, almost all of us did it wrong. So we want to know that I really want to have the Snow White, right? But I'm going to buy a number of boxes, right? So how many boxes should I buy so that the probability is greater than 98%? All right. So we want the probability to have at least 1 Snow White is greater than 98%, right? So suppose I buy n eggs, right? Suppose I need to buy n eggs. So to get at least one slow white, the probability will be 1 minus 5 over 6 to the nth power. That is the probability getting at least one slow white in nx. Alright. This is the probability getting at least one snow white in buying nx. Alright, never mind the boxes, we'll divide by 3 to get the number of boxes. Right, let's focus on the number of x. Alright, you need to open nx, and to get at least one slow white, the probability will be this red number, and this red number is greater than 98%. Alright, so now we have to use log to help us to do this calculation. Let me do it step by step. Right, we have 5 over 6 to the nth power will be smaller than 0.02. Right, 1 minus 98%. So we take the log, and log 5 over 6 will be smaller than log 0.02. And then we divide the log 5 over 6 over the other side. Log 0.02 divide by log 5 over 6. But note that 5 over 6 is smaller than 1. So log of 5 over 6 is a negative number. This is a negative number. Alright. When you move a negative number, you should swap the direction of the inequality. So you do that number on the calculator, you discover that n is greater than 21.46. Alright. So the smallest integer to do that will be 22. Alright, so the smallest n will be 22. That means you need to open 22x in order to get at least one snow white with greater than 98% probability. Alright, 22x, that means you need 8 boxes. Alright, 7 boxes will only give you 21 8. Alright, so at the end you need 8 boxes. This is the final answer, 8 boxes. Alright, you need to get 8 boxes. You had 24x, but because they comes in free, so you have no choice. But if you can buy them individually, you don't have to buy 24x. All you need is to buy 22x. Alright, and then you can have the probability greater than 98%. Alright, if you have doubts about any of this question, go back and revisit, watch the video again. But all these 5 questions, they have the same idea behind, right? Note, pay attention to this blue number. How many times this branch is going to repeat, okay?